Let's start this out kind of along the same lines I did with Georgia the other day, because you got to start somewhere. And people are gonna. One of the things they're always asking me is, "What's wrong with the Big Bang? How you know what's wrong? What's out?" Start from the very first beginning of it. Almost 1,000 years ago, two different civilizations first saw a nebula in the sky. Star. They called it a star exploding. I mean, 1,000 years ago, man didn't even know what was out there. He thought this galaxy was the extent of the universe. So it was only normal when he looked up and he saw a big bright flash that even appeared during the daytime. He thought it was one of those little balls of light, little star up there that exploded.
Right.
Okay. It wasn't until a little over 100 years ago in 1923 that Hubble first surmised that there were galaxies out there. And the telescopes were just getting good enough where you could differentiate between what they called a blurry nebula and an actual galaxy.
Right.
And then it came in with the idea with the redshift, and everything else followed. His idea of a tuning fork diagram where there are three separate types of galaxies. Uh, well, he was wrong on all 3 points. The problem was, for 1,000 years now, we've been describing astronomy on the basis of stars exploding. That leads to this mistaken idea that we can measure the distance to the stars by the redshift, by how they're going about. And the worst part is by saying these nebula are stars exploding.
Right.
I first thought of this idea of the cosmic bubble and the mother rock was when I discovered the mother rock, which was a totally different explanation for not only stars, planets, and galaxies, but the establishment of space itself. Uh, so you go along with everything that they said for 1,000 years in astronomy, that stars are exploding and they're seeding the galaxy, this and that, everything else. Well, you might describe a little bit of the area around a galaxy, but there's a whole lot of area in between the galaxies that, in a balanced universe, that's not going to be void. That's not going to be empty space. Now, about 1923, when they discovered other galaxies, nobody ever put that into the equation by saying, well, maybe, Hubble come out and said one of his three laws was that the nebula had nothing to do with galaxies. But he did that. He said that with zero evidence. Nothing. Nothing at all that had any kind of backing for the statement or anything for the idea. Because at the time, we had barely had telescopes enough to even see the galaxies, let alone any detail or anything else.
Right.
Okay, around about the 1930s, 1940s, when the Big Bang was starting to gain traction with Hubble's findings. You got to understand, the entire domain of astronomy was the same way it was right now, dominated by one idea.
Mm-hmm.
When Hubble came in with this idea that there are other galaxies out there, they pretty much tried to laugh him out of the country.
Right.
You're an idiot and that. But when he came across with variable stars, showing that had something to do with the distance and being able to link their light and their periodicity in with their distance, that showed that the galaxy was clearly outside of ours,
right,
and separate. That was Andromeda. So then we discovered all these other galaxies. Now, about the same time, journalism was changing. The peer review system had been around since the 1600s in England.
Right.
It was started as a scientific community. Mm-hmm. People who were really a part of the sciences deciding what should be published and what shouldn't, mm-hmm. according to the validity of the claims. Well, in the early 20th century, it started becoming dominated by the journalism industry. Young guys coming up with theories and ideas, young engineers and scientists were incentivized in order to get their publication, in order to get their work in there, they had to do a review of somebody else. In other words, there were free reviews for the journalistic magazine, but journalism still paid the price because it locked out any views that weren't popular, that didn't make money.
Right.
So if you try to put in a story, how Narp did it, he started back in 1953 trying to tell Edwin Hubble that he was wrong. He was his assistant. That's a whole nother story. I actually had an email. I talked with Hal Narp
That's
for 5
amazing.
years. We both worked together on his story of the parent-child galaxy. It bit
Mm,
with my mother rocking. Anyway, these are all long stories involved, but
amazing
the main
story.
outcome, the main outcome was what you're looking at now. This one theory has held its hold over the science industry because it literally shuts out anyone. It has a tangible fear.
Mm,
I've been threatened with jail more than once.
mm,
I was escorted off campus just because I said the Big Bang was wrong. So I'm no stranger to any of this. On the
mm.
same hand, I have met some of my idols. Have you ever heard of Fred Hoyle and Jeffrey Burbridge? I actually went out to L.A., San Diego, and met Jeffrey Burbridge back in 2008. Got to
Wow.
shake his hand. That was the greatest thing I ever saw. I come out the hallway and, I have a habit of just dropping in unannounced. And the next day I come in, he's there. His voice is booming out of the hallway. Are you a physicist? What? Are you not a physicist? How do you understand the universe if you're not? I'm like, oh my goodness. I had a professor of mine teach me how to deal with this because he knew this is what I was going to go into with somebody yelling at
Oh.
me, screaming at me. And it just worked perfectly. I had him calm down in minutes. He shook his hand. He said, you might not want to shake my hand after that.
Aw.
But what was supposed to be a 15-minute conversation turned into 3 hours. And
Wow.
by the end of it, he was saying, Mother Rock, what is this Mother Rock? At least 4 or 5 times. But he had papers. He had so much work to do and everything else. To me, it was just a delight to have met the man and been in his office.
Absolutely.
but that the Big Bang's wrong.
Big Bang is
Yeah,
wrong. So,
I knew this. I knew this when I was probably 9 years old.
and what is the mother rock and cosmic bubble? Can you describe those concepts for us?
I can describe the concept to you, and I can even show it to you, walk you through. You see my video.
Mm-hmm.
I don't know if you have or not. Let's see.
I've seen
Here
quite
we
a few of
go.
your
I
videos,
didn't.
Fred. Which video are you talking about?
Oh, that's right. I got about 100 a month there, don't
You do. Be specific.
I? The one that shows about the Mother Rock.
Because just not to preemptive strike or anything, but when we started talking about this, doing this interview today, because a lot of the observations and predictions that you've made with your mother rock and cosmic bubble theory were proven through the or observed through the Voyager mission.
Yes, Voyager 1 has reached the other side, the far edge of the sun's protective bubble. But what it's finding out there? It's rewriting the rules of interstellar space. After crossing the heliopause in 2012, Voyager 1 became humanity's first emissary to the stars, venturing where nothing man-made had gone before. And now, after a nail-biting communications blackout that lasted months, the spacecraft is sending back data that's forcing scientists to rethink everything they thought they knew about the space between stars. What Voyager 1 is detecting in the interstellar medium isn't just surprising, it's transforming our understanding of the galaxy itself. The craft's instruments are picking up phenomena that no one predicted, revealing a cosmic environment that's far more dynamic, structured, and mysterious than our models suggested. This isn't just another space story. This is humanity's first direct sampling of what exists beyond the sun's reach, and the reality is more fascinating than fiction. New groundbreaking data. Something's off out there. What Voyager 1 is encountering 15 billion miles from Earth is unlike anything scientists predicted. The spacecraft's instruments are revealing an interstellar environment that's far from the empty void we imagined. The first shock came from the magnetometer readings. Voyager detected an interstellar magnetic field that's tilted sharply compared to the sun's. Scientists didn't expect the fields to align, but this steep misalignment suggests a galactic-level boundary. The readings point to something more significant. Voyager may be near a magnetic turbulence zone, where galactic magnetic fields twist, reconnect, or tangle. These aren't small ripples, they're fundamental structures that could reshape our understanding of how the galaxy works at its largest scales. Then there's the plasma. Voyager's instruments have picked up multiple density spikes, like pressure waves moving through space. These aren't random fluctuations. They indicate Voyager might be passing through actual shock fronts left behind by ancient supernovae that exploded thousands of years ago. And the silence of space? It doesn't exist. Voyager's plasma wave instrument has detected constant low-frequency oscillations. It's not emptiness out there, it's something whispering, a cosmic hum that permeates the space between stars. Think of it this way. Voyager isn't drifting through emptiness. It's more like flying through an invisible fog, and every few months we find that the fog is layered. Some parts are hotter, some parts denser. And that hum, that might just be the weather of interstellar space. What's most surprising is how structured the interstellar medium is. Instead of a uniform sea of particles, Voyager is finding distinct regions with their own properties, like sailing through different climate zones on an interstellar ocean.
So I want to get to that. But first, in order to understand that, we have to understand what is the cosmic rock. So what is it?
Let me walk you through it. I have a video on there that does that, and I'll give you a link to it.
Perfect.
But here's basically what it is. This is a cosmic microwave background. Right? They're saying these are all the expanding of the universe as it's blowing outward. Right?
Mm-hmm.
I want you to look at this as if you were looking at some bubbles in a fishbowl. Now you see what I'm talking about?
Yeah.
These are bubbles immersed in liquid or in a fishbowl, right? Kind of like this right here, where they're globules. You see what I'm talking about?
Yeah.
These globules floating in space. Now, in the cosmic background microwave, these are actually electromagnetic fields surrounding galaxies. So this is a three-dimensional map of galaxies in space. Each galaxy is surrounded by an electromagnetic field. You can't have plasma, you can't have stars without electromagnetic field.
Absolutely.
And this is how it is up there. Eh?
Mm-hmm.
Now, these are cosmic bubbles. Here's a picture of an area. This is pretty much what I'm talking about. You can see how the shape is the same. Here's another picture, how the hot air is here. This is a galaxy, another galaxy. Here's a small galaxy that are inside this field, separated from these vast areas of cold. Right?
Mm-hmm.
This is areas of this right here. These are areas of no radiation. These were discovered back in 2007 by an astronomer and his students, University of Minnesota. And it's showing you the same thing. You see the structure?
Mm-hmm.
It matches the picture there.
Yeah.
Cosmic background. Okay, so that's what they're finding. There's another one I have on here about the voids in space that they're finding now. Oh, this is what it looks like. This is towards the center of our galaxy. This is A star. See the
my dog.
The boundary layers.
The boundary layers.
You see that?
Yes. This separates them. So
yeah, there you go. So the area inside of here is spatially separated from the area outside.
Mm-hmm.
Now, here's what's interesting is I had taken a picture, and when I ran it through the scanner, this is what came out.
Wow.
Was you could see the same structure as what you're seeing here.
Mm-hmm.
Same thing I just showed you there. This is inside the galaxy, so I can't say outside is line, whatever. This is just higher intensity radiation. But here you can see the same thing. Structure around a galaxy, a structure outside of the galaxy.
Mm-hmm. And a very
So that's what
defined
causes.
line.
Yeah. It's basically separated. This is an area like it's found out here. This is an area of no radiation. Or, like I like to say, it's antimatter. This is all antimatter out here, just floating around out there. And every now and then, the mother rock gets a big old gulp of this antimatter, and it uses it to make plasma and make stars.
Mm.
Okay?
Oh.
Now, we'll get into the mother rock.
Okay.
Here's the mother rock. Oh. You know, you've seen a picture of the Sombrero Galaxy.
Yeah.
Yeah, it's a big flat one. Well, imagine the line around the center of it is actually a line of planets. Right there. Okay. That's not dust. This is millions of light years away. How the hell can you see dust? Those are planets.
Yeah.
See that?
Mm-hmm.
Those are all planets.
Like rocky objects, or maybe gaseous.
Say you had this picture of this rotation here, this ring, and this ring starts shrinking down to where it comes into something like this.
It pinches.
It pinches into that. Now, that ring keeps gravity, makes it get smaller and smaller, spins faster and faster until it turns into a globe with a hole through the center of it. Here we go. The first ring starts out, then it spins down, gets down smaller and then smaller. There's no gravity in the center of this. Understand, all the gravity is in the mass of the object. I'll show you in a minute. But as this gets smaller, the center remains open because it's spinning.
Okay.
You know, centrifugal force keeps it open. It also makes a big old chamber in the center of it. Yep. Now that big old rock gets close to the edge of this bubble here. It takes in some antimatter. Yeah.
Like the eye of the storm. Like the wall in the eye of the storm.
Yeah, yeah. And then opens a wall through an electromagnetic vortex. When it's spinning fast enough, it reacts to the antimatter on the other side. It opens a hole and it fills up the center chamber, just like this. Then it starts a plasma jet out either side. And either of these plasma jets build stars. You have electromagnetic field right here that ionizes the gas, creates your Z-pinch right here. Nucleosynthesis and everything else.
So all objects in space from the macro to the micro are bubbles with the so if it's like a cosmic rock, I mean, is this just cosmic or is this also atomic, molecular?
Oh, this is everything. It's from cosmic to atomic and the whole works. Since you asked about that, I'll give you a quick shot right here on the wall. Let's walk up to the wall and see what we've got here. Here's in space. I tell you, it's two areas of space: outside, inside plasma. It's infinite, eternal. It's never born, never birthed. It's always been there, always will be. Covers everything. There ain't no expansion, and it acts like this. Here, mass is inside of antimatter. Like I just showed you, the bubble inside the universe. Now I go through everything, the mother rock, all the way down to what Voyager was talking about, solar systems, rogue planets and stars, on down to the plasma, the expanding Earth, all reflections and mirages. The picture I told you about reflections in the climate from a snowball Earth to field control patterns, alternating atmospheric shadow bands, all the way down to propagation, all the way through life, all the patterns, Fibonacci series, pi, golden ratio. Life in lines 2 miles deep, evolution history, no hair, abiosynthesis, photosynthesis, rock life in cells, all the way down to the atom. The atom is like a transceiver. It sends and receives the signal back and forth. Has north and south hemispheres to it, which are doing the exact same thing as the hemispheres on the planet and everything else in space. You come on down to the end of all this, the atom, what you see is antimatter in the center of the atom surrounded by mass. The exact opposite picture of the galaxy.
Yeah.
So it's antimatter mass recycling through this continuous cycle.
Wow. So what you've been studying this for quite a long time,
About 25 years.
right? And
And,
and
and
and so
25.
25 years ago, you made some predictions with this model that we weren't able to see because just like the astronomers in the 1600s couldn't see in outer space, but now Voyager made it to like the cusp, like crossed barriers. So we're going to talk about barriers, talk about boundary layers, like boundary
The
layers and
one
our
done.
ability to understand because we had boundaries put on us, and
The, the,
now we can see.
the thing is, it has structure. It's not just boom there.
Right.
It has structure. These layers support themselves, and everything in them support the layers. The layers support the rock. The rock is a generator for the field.
Right.
Space between stars isn't the uniform void astronomers once imagined. Voyager 1 has revealed it's more like an ocean with currents, eddies, and weather patterns, all invisible to our telescopes until now. Since crossing into interstellar space, Voyager has passed through at least 2 distinct interstellar cloudlets. These aren't visible clouds like on Earth. They're regions where the density of plasma, dust, and gas suddenly changes, often by factors of 2 to 3 times. What's remarkable is the fine structure Voyager is detecting. The probe's instruments show evidence of structured plasma ripples, almost like atmospheric fronts in space. These aren't random. They have clear boundaries and characteristics, suggesting large-scale organization in what we thought was chaos. NASA scientists now believe the Sun is currently moving through what they call the local interstellar cloud, and Voyager is helping define its outer edges. This cloud is just one feature inside the much larger local bubble, an enormous cavity in the interstellar medium created by ancient supernovae. The implications reach all the way back to Earth. These density shifts in the interstellar medium could affect our planet's exposure to cosmic rays over millennia. As the solar system drifts through different interstellar environments, the radiation environment at Earth subtly changes, potentially affecting everything from cloud formation to mutation rates in living organisms. What Voyager's showing us is that the edge of the solar system isn't an edge at all. It's a messy, chaotic swirl of plasma, radiation, and magnetism. Not empty space, but space with structure.
I'm so excited because your checklist goes on and on.
Oh, I go way back to when I was making predictions that came true over the last years. I literally have thousands of them. Everything from just simple discoveries to whole new ideas and concepts that have been confirmed by this. And here, I'll take you through everything, showing you the mother rock if you want to do that first, or I can just show you the end result is right here. Okay,
I remember
this
those.
is where I'm sitting. This is a picture of Orion right there.
Mhm.
This is the sword in Orion, where I'll show you eventually. That's the mother rock, and there's the plasma jet that's producing stars. Okay.
Okay.
Now, this is what I like to call a baby rock because it's not only one jet coming out of it, and the field has not fully formed because it's straight line across here. But then when the other jet blows out this side, it's going to look like this. Here's laid over sideways what I'm showing you. The jet coming from the mother rock.
Okay.
Here's the center of our galaxy.
Yeah.
There's the plasma jet coming from the mother rock right there. There it is. That brown shape right there.
Uh-huh.
There's the jet. Exact same picture as this. See the jet and the rock?
Yeah.
But now we have the jet on the other side too.
Yeah.
This is a full blown, and I know it's a mother rock blown out of the well because you can see the torus shape of the electromagnetic field around it. I have that shape in other pictures of it, and it's really cool. But what you got here is the mechanism that makes a spiral galaxy.
Mm-hmm.
See how that's turning sideways away from us?
Yeah.
And we came from this jet here?
Hmm. It looks like a spindle.
That's pretty close. This thing is spinning real fast,
Hmm.
creating this field, this powerful field. It's a big old magnet generating this field, and that field is what supports the cosmic bubble that I showed you right here.
So the
This
center of
bubble
it is a polarized magnet.
Yeah, well, polarized. I mean, all magnets are polarized. It's an electromagnetic source of power. It's a generator.
Okay.
The easiest way to describe it is just as it's a generator that creates this cosmic bubble that allows our existence.
Mm.
And like it showed in that picture of all the bubbles, they're interconnected through the entire galaxy.
Hmm. Like chains, like bubble chains.
Yeah. There has to be some kind of frequency involved here
Hmm.
that has to attach it to all galactic centers to keep them from separating from that bubble.
Right, and then they turn into Laniakea eventually. Like they just get like
Well,
the
they
birth of
recycle.
clusters. They just get
Yeah.
the layer again, like the boundary layer gets bigger and bigger, and it's full of smaller bubbles.
There
There's
you
like
go.
smaller bubbles inside of a bigger bubble, inside of a bigger bubble, inside of a bigger bubble, but it just keeps going because it's toroidal and it takes itself back in the antimatter. Like the like in the center, I'm trying to visualize it and make sure I'm understanding, because you said there was the centerpiece where it opens up and takes in the antimatter to create more.
Yeah, you're talking about the mother rock itself.
Mhm.
Here's how it starts out. Mother rock starts out, then turns into a barred spiral,
Mm.
right?
Mhm.
And you see as that barred spiral starts to turn sideways,
Mm.
it turns into a regular spiral, and then a large spiral. And here at this point, these spirals are birthing new galaxies. The dwarf galaxy we see, the small jet Magellanic Cloud, large Magellanic Cloud, they were all birthed from this galaxy.
Mm.
And if you follow this line of energy of this galaxy, here's about where we are right here. Here's our galaxy, center of the galaxy. Here's a small Magellanic Cloud, large Magellanic Cloud, and there's an ion stream that follows here, and it leads right to Orion.
Mm.
Hey, there's Orion.
Mhm.
Okay.
And there.
Now here's how the mother rock forms. This donut shape that these planets circling a galaxy, it takes on a torus shape, right? If I cut that shape in half, I'll show you like this. I can see either half of the donut or the torus. You'll notice that the center of gravity is in the mass of the object.
Mhm.
So it's pulling from the center outwards, right? You see how that works?
Mhm.
This big old shape here, all the mass is in this outer ring. So there is no gravity in the center of it. It's actually pulling space apart and ripping it outwards. But as this collapses smaller and smaller and gets that tube go through the center, keep in mind, we're talking about an object that is several times the diameter of our solar system.
Right.
Probably 600 to 700, maybe a billion suns in mass, the larger galaxies will have. And once it gets that charge, it'll nestle up to the edge of the bubble and get a charge of antimatter right down in the center. And when it does, it starts to blow off. First, it just blows off one plasma jet, right?
Mhm.
And after this one's been burning a while, it starts to exceed to the other side. It blows off the second plasma jet. And that's when it starts building a barred spiral.
It kind of looks like a Pokeball.
Yeah. But that was that same
Oh,
picture of
Pikachu's electric.
the. Anyway, there's a picture from Eric Lerner's book. And
Oh,
you can
wow,
see the
yes.
electromagnetic field of the rock itself. And there's the plasma jet that we came from. See? So when I tell you that Orion is a new galaxy, I'm telling you that we're actually closer to Orion than we are to the center of this galaxy. So we may be under the gravitational pull of Orion and that mother rock over there.
Oh, wow. It's
That's
really a
cool.
significant constellation, like historically. I have some interesting theories about it myself, so you know, that would be.
Oh, I got some shit that's gonna blow your mind, girl. I got, I got some shit that's gonna blow your mind.
So,
You see that? You
mhm.
familiar with that one?
Yes.
Can you name them for me?
Oh, I can't name it for you.
Yeah.
The
That's M42,
M42.
M43, and the Sword Nebula in Orion. All right, you
Oh,
looking at it real good?
yes. I've worked with that picture before.
Do you see this here?
Yeah.
That's a big old ball right there. You see that?
Oh, yeah.
You see the reflection of the ball back there?
Yes. Yes.
You never saw that before, did you?
No, I mean, it looks like a bird to me.
But here's the trip. You see the black segment here? That's the smoke from when it took in the first
Okay.
antimatter charge.
Okay.
Now, if you see how it's divided, going this way and that way and that way, this is a reflection of the other side of it.
Oh,
And
yeah.
if you extend that picture out
Yeah.
right here, you see now that this whole structure here is another reflection of this.
Yeah. They look like lens flares.
There you go. But now I've done showed you 1, 2, 3, and what I was just showing you about that black smoke coming over there.
Yeah.
That is the running man back there.
Wow.
So this entire picture back here, these are all layers. Did you see that video I put up showing the truck with the layers from the headlight on a hot surface?
I don't know if I saw that one, but it's like a mirage.
Yeah,
Like the way it's like
yeah,
cutting through the.
that's exactly what this is a mirage. This is a rarefied atmosphere in space, and these are reflections. These are mirages. Do you see the horse head?
Yeah.
Do you see how it's a reflection of this? Do you see how this entire picture here is reflected right there, back and forth?
Yeah.
You see that now?
Yeah. I do. That's crazy.
You're looking at something that is on the inside of the cosmic bubble that surrounds us. That's all a reflection. The only thing that's real is the explosion of the mother rock. All this up here, that right there, Flame Nebula,
Mhm.
if you look down real close at it,
So it's a projected reflection, like the camera obscura effect, kind of like it.
there you go. Well, just like a mirror.
Yeah.
But it's not just a mirror. There's thousands of them. When I show you this picture and I say, "Do you see the reflections?"
Yeah.
I'm going to show you that. I am going to show you this. Yeah. I don't know. That doesn't. There are layers of stars in here. There you go. See those lines?
Yeah.
See that?
Yeah.
See the straight line here?
Yeah.
Those those are structures. Our whole tells the whole idea of astronomy is based on a vacant space with nothing out here. And here I'm showing you a space full of structures.
Right.
That's what so I love so much about that information from Voyager 1. It keeps using that word structure.
Right. And
That's what I've used.
and layers too, didn't they talk about
Oh,
layers?
yeah.
So so
Yeah.
let's look through your checklist. What did Voyager confirm that you predicted?
That's the old chair. Okay, can we see that?
Yeah.
That was just some of the stuff that I thought was interesting. Now, they're going to say, oh, we knew about the medium and we knew about plasma and we heard about the layers,
Hmm.
right?
Hmm.
But they didn't put any of that into a picture.
Hmm.
I explained what the interstellar medium is. how it's clouds of plasma, just like I was showing you the plasma that's coming from the mother rock.
Mhm.
It burps. Poof, poof, poof. Those are why you have areas of plasma that are denser than other areas.
Mhm.
So that's what I'm getting at. They can't explain anything that I have valid explanations for every one of them.
Unexpected patterns, galactic rays, and cosmic pressure. The deeper Voyager 1 pushes into interstellar space, the stranger the environment becomes. One of the most shocking discoveries came immediately after crossing the heliopause. Voyager recorded a sharp spike in high-energy particles that nobody anticipated. These cosmic rays, accelerated to nearly the speed of light by distant supernovae and black holes, bombard Voyager at rates far higher than inside our solar system. The jump wasn't gradual. It was abrupt, like crossing an invisible threshold. What this reveals is profound. Our sun's protective bubble shields Earth and our solar system far more effectively than we thought. We're living in a cosmic oasis, protected from the harsh radiation that fills interstellar space. But the pattern of these cosmic rays isn't uniform. Voyager's detectors have measured subtle variations that suggest something even more intriguing. The interstellar medium may have natural corridors of radiation, like cosmic highways where particles preferentially flow. Could Voyager be detecting a cosmic pressure gradient, hinting at larger galactic structure? The data points to exactly that. These aren't random fluctuations. They're systematic patterns that map onto something bigger than we can see directly.
The layers themselves are actually caused by the mother rock. As it's spinning, it's putting out what we call magnetic layers, but we keep calling them north and south. And north and south doesn't mean a damn thing in space.
Right.
So I had to find out exactly what was a magnetic force if it wasn't north. Look, I'm talking to you while I got the camera the other way.
Mhm. Mhm.
It's all right. You're gonna find me good at this. I'm looking through my book. There's one picture I got.
That's okay because you're kind of pointing it toward a magnetic field, or like the
Yeah, well,
cross section of
yeah,
the galaxy. And-
here it is. These are the layers. I like to tell what fabrics. No, they're not fabric of space. I was running my pictures from one of my astronomy books one day, and it was a clear, glossy blue picture. And when I ran it, these lines popped up. All right.
Mhm.
And when I ran them a different way, they showed different lines. Every time I ran them, I turned them sideways 90 degrees, I got a different set of lines. But what really intrigued me was I had spotted these lines before. When I was pointing out the star lines, the reflections and mirages I was talking about,
Mhm.
I had already seen them in these pictures of the Magellanic Cloud. This is LMC. And here we got the same thing as with Orion. That's Orion, the big cloud, and then the three reflections.
I
You see that?
Yeah.
Those are reflections. You can see the layers, right?
Mhm.
I, and when I look at this here, I was looking at, well, I could see these lines of stars going up and down. You see them?
Yeah.
Everybody gonna say, "Oh, that's a trick of the eye. That's just a random order." And I said, "No, that's not random order. There's no random order in that."
Right. That's a string of pearls.
Thank you. String of pearls is what they love to call them. Look at that right there.
Mhm.
But when I was looking at this picture, I realized it's flowing this direction, then it flows down. And look at that. There's the picture I took that showed those layers. It's flowing the same direction and then flowing down.
Wow.
So that right there says there's a disturbance in the electromagnetic field that curves the field. That makes these layers. And the only layers they could be would be magnetic. At the time you realize I took these pictures probably 2001. We had just barely got around to acknowledging that there was magnetism in space. We flat out, and when I say we, I'm talking about astronomers, big bangers.
Right. Humans, right?
Yeah, there you go. We had firmly declared there was no electricity in space, and up until 1996, I believe they said there wasn't no magnetism. But then all of a sudden they found magnetic fields and all. And thing about the current theories is they all cause and effect. They get cause and effect backwards. They'll take a picture of something and then try to explain it. Problem is, the next time they come along, that picture changes. They have to go back and change the character of the object they already observed. And that's not science. I hate to tell you that it's not science. Whereas when I say everything here, I mean literally everything in this book I saw before it was discovered. I wrote about this stuff. I wrote these pictures that I showed you of the mother rock in the center of our galaxy. They weren't around 25 years ago. These other pictures that we're seeing now, I have literally thousands of stories that show the changes over the years. But back to where we were. So this is what I'm setting up for. As you were asking about plasma in a checklist.
Yeah, the plasma and
Well,
the checklist and the layers that
yeah,
you're definitely getting into the layers.
there's the layers. Okay, now here's the deal with these layers.
Mhm.
If they're magnetic layers, they're of equal strength. You know, each area is northward one side, southward the next side, northward, southward.
Mhm.
But an idea was coming about here lately that northward and southward are actually left and right electron spin.
Right. Absolutely. Wow. I'm so glad I'm thank you. That's something.
Well, they are.
Yeah.
Plain and simple.
Right hand rule,
It's
left hand
spin.
rule.
That's what I talked to George the other day about. George is an engineer of 40 years. He was in charge of human spaceflight and computer spaceflight and flight. He was in the launch room of just about everything NASA launched in the last 20 years.
Wow.
George Salazar is one of my best friends, and I guess he's now one of my best followers. That's where I told him, I said, you know, one of the big things in electrical engineering, what you've learned your whole life is the right hand rule.
Hmm.
He says, yeah, of course. He says, well, what makes you think there's areas in the universe where there's the left hand rule? Magnetism is supposed to be of equal strength
And we think
to
about
have a
like any
balance.
like Windershins and Dysel, right? There's always that like right, left,
Yeah.
like the northern hemisphere and the southern hemisphere, things spin in different directions. You
There
know
you
what I
go.
mean, in the sphere. So I mean, it makes sense. That makes more sense than necessarily calling it, giving it a like a spatial orientation when there's no up in space.
Mhm. But these are layers of right spin, left spin,
Mm.
north, south, red, blue, whatever you want to call them, don't matter. We'll touch it on later on where red and blue colors are caused by right left spin.
Okay.
Uh, we now know that they have discovered the particle that can carry both forces, just depending on which direction it's spinning. It can be spinning one way carrying gravity and spinning the other way carrying repulsive gravity.
Wow.
The same particle.
Right.
And
Just
I
that
told them,
opposite force.
it's the same way if you see two springs spinning this way and the other one spinning, they just intercoil themselves.
Hmm.
So that's the basis on all this. The toroidals, the torus, the groupings of atoms, everything is based on that right hand and left hand spin. But here's the kicker. And I always wondered about it too. I was reading it not too long ago again, how magnetism is treated as a balanced force. That's always north and south are balanced. Even in solid materials, solid gas and mass. Well, uh, they're not. They are balanced in space. whatever area you're in has a right-hand domain, northward domain. All the ions, all the flow, all the magnetic turbulence that Voyager found is all going one direction. Your planet is in this immersed atmosphere. So all those northward elements coming out have somewhere to go, but all the southward elements don't. They're forced back in.
Mm.
That's where you get the craters on the moon and Mars and everything else, all the plasma craters. Those are the southward elements, gravity, forced back into the planet because there's nowhere for them to go out. The only ones that can go out are negative electricity, positive is in towards mass.
So would that be like the Mid-Atlantic Trench and like the South Atlantic Anomaly?
Mm-hmm. Those that's a magnetic reversal. That's exactly what we're talking about. Is when that planet you're on is in an area of right-hand dominance, and it drifts. We're always circling around, drifting too. It drifts from the right hand to the left hand.
Right.
Then left hand becomes dominant.
Right.
There you go. See.
I'm seeing.
But the thinking here is very logical because it requires what you have to call a feedback loop.
Right.
Direct energy going out directly does have no wavelength. It's just straight out. You have to have something for it to hit and bounce back to compress that wave.
Okay.
That's called a feedback loop. Now,
Mm-hmm.
all of a sudden, you have magnetism outside of your planet developed on this feedback loop that goes between those electrical layers and to your solar system, and it denies everything. That's your right-hand rule.
Right.
Now, when you shift over to the next domain where it's all left-hand, the magnetic field of the planet shifts. And the way it does it is through these layers. Say the layers are right here like this. If you're coming down from space, you're coming out of space, coming down as gravity would. Let's say you hit the electrical seas first. After you go to electrical, you're going to hit right hand, then left hand, then down. Magnetic reversal is going to be the opposite. It's going to come in left hand, then right hand. So you're talking about a major crisis for biological systems. Because all left hand, all right hand people, 80% of the people may not survive the magnetic reversal.
Well, if
don't go
it
telling
happened
nobody that yet.
instantaneously, I would think, but if
No.
it happens gradually
It's
over
not.
time, because it's like each generation, because it happens over generations, right? Like a graduate, because it's moved and it is moving quickly, but it's definitely not
it happens every 120,000 years.
right. But it's like a Doppler effect kind of a thing where it happens a little bit and it shifts, it like wobbles, just like the Earth does. So if it does that over extended generations, each new generation would be adapted to the magnetic environment into which they were introduced. And even if it changed through their lifetime, it was changing like a minimal amount that the next generation would also be adapting to it. So, I mean, that doesn't just go for humans, that's like all the species.
Right. Plants, animals, everything. You have a considerable amount of systems that are ambidextrous, you could say. Can adapt to either way. So the point being that that's what a magnetic reversal is, going from one area of space to another. Electricity stays the same. The fact that Voyager 1 made it through I'm going to call it a sheath. It's a current sheath because of what it is. In between these layers of magnetism, you're carrying a layer of electrical, negative electrical. Negative electrical is outward, expanding. All the cells from electron, they act the same in space. That's what's creating these layers. These cells are now pressure waves, voltage potential between them. That is the structure of the galaxy. Is these layers and waves. So since Voyager 1 passed through one of those for the last few months, it just said garbage. It couldn't do nothing. But it was only short lived, so I knew that's what happened. It hit that electrical. They called it a wall of fire because of 50,000 degrees Celsius.
Wow.
Right? Do you want fire? Stick your finger in a plug and see what kind of fire you get.
Right.
You talk about a temperature raise. These layers are, I don't know if you call, what they're called, omnipotential, whatever. You can probe them anywhere, and you access the entire voltage of the entire galaxy.
Right.
Right?
Tapping into it.
You're tapping into a layer that surrounds the entire galaxy. So you're talking about millions of volts. Here's the trick, though, is they didn't expect to find electricity in space, right? So they didn't put any systems on Voyager 1 to measure electricity. They have a magnetic spectrometer on it, they have a plasma indicator, but they don't have anything to tell them what the voltage was. So this wall they just went through, all they know is, oh, it was incredible temperature. Well, how many volts did you encounter? Oh, we don't know. It's pretty much like a bird sitting on a wire.
Mhm.
The potential becomes the same, and a bird doesn't get electrocuted because he's not grounded.
Right.
Voyager 1 performed the same thing when it went through this sheath, right? It became the same potential as the sheath itself. It just passed right through it. The messages got garbled because of the radio static of the field itself. You're trying to send signals through that. But the fact that it made it to the other side of that field, of that sheath, and is still sending back messages means that maybe the electromagnetic field will not have a serious problem on our electric grid.
Mm.
Right? My dad was an electrical engineer. He was he was one of the big dogs on Black Book projects for Lockheed Missiles in space in the 60s. Yeah, I got papers. I got them online where he was involved with lunar habitats and spaceports here back in 62, 63 when they first started, before we had even really got into space. But climate change, however, is a whole nother ballgame. Climate change has to do with the age of the planet. These planets all start out from the mother rock. That's why I told you about the reflections,
Yeah.
double layer, Eta Carina. And then when I get back here is where it starts to turn.
Mhm.
Turns into bar spiral into a spiral. And from there, let's zoom back in. I'll zoom back in right there. Right in here is where the rock, the plasma blows over the rock. And there you see it. Solid planets blow off this edge of the stream. Gaseous planets blow out the edge of the stream. And the stream itself builds stars. That's all.
Nice.
Yeah.
Yeah. So it's kind of reminding me of the yin yang symbol
It's very close.
with that bit of rock in the center and the way that it's like, it was like pulling it around and creating a little bit of itself with the, I don't know, because it's the matter and the antimatter swirling around. It's very yin yang. It's very,
Well, it defines the balance.
yeah.
It defines the balance between the matter and antimatter. What I've done here is something nobody has ever even come close to, is this question for the last 100 years of baryonic symmetry.
Mm.
That everybody knows, all the scientists knows, everybody who studies it says there's an equal amount of antimatter and antimatter in the universe. I'm like, well, here it is. We're surrounded in it.
There it is.
This was did you see what I was telling you about the reflections in Orion?
Mm-hmm.
Imagine this is that one bubble in Orion. There's the bubble behind it. This is Eta Carina, another nebula, which is actually, this is a mother rock exploding, and that's its reflection.
Wow.
See that?
Yeah.
This is a reflection right here. And that's just in front of it. Look at the difference in light. Right? Now you see this out here?
Mm-hmm.
That's on the layer. Like it was a piece of glass. Or if that was nestled up against a mirror. You see that?
Yeah.
If I turned it up this way, it looked like a beach ball on the water. That's one of the pictures that I gave
Oh, like
George.
a reflection. The ball and its reflection.
Yeah. Oh, that's a new mother rock and its reflection on the layer.
And we see examples of this like in bubbles and like the oil on water and the surface, like between the surface tension, and I think about the Debye screen effect, which is more of like a density layer thing, but there is like definitely a boundary, like they find the boundary of like thicknesses, of particle density that change, and it's a very abrupt change. It isn't a gradual gradation that's, you know what I mean? Like there's a definite, like you're saying, structure, edge, circumference.
Yeah.
It's a
Structure to
different
all of it.
point.
There's
Yeah.
Orion. Right? That's the Sword Nebula in Orion.
Mm-hmm.
See how that's a reflection of this?
Yeah.
This is Eta Carina, the very next nebula behind the Crab.
Mm-hmm.
That's the top of it. Looks like a beach ball in the water.
It does. When you say
That's a
it like
reflection.
that, then you can't unsee that.
No, you will never unsee it. You will never unsee that. But that's the basis of everything in here. Is that I've discovered these reflections. I've discovered this object that creates a galaxy and a space around it that supports that. I got all kinds of crazy stuff here. You make the rules of the game, and I'll use those rules to whoop your ass. They made the rules of the game. They give me a book telling me the laws of physics, and I said, well, you're violating the laws and everything on the whole work you got. And you look at my work, not only is it comprehensive, it covers every single thing, but it does not violate one single law of physics. If anything, it upholds all of them and confirms them as being real and true. That's what I live by. You make the rules, and I'll whoop your ass with them. The best cartoon I saw just lately. Somebody had a meme up that showed a daddy talking to his son, and he's telling his son, "Question everything," and the kid says, "Why?" See, it takes a quick mind to catch that one. That was me. That was me.
Oh, good.
They tell me, "Oh, this is what's happening." Prove it. Show me the source of where you're getting that. No, that's just the way it is. No, that ain't gonna cut it.
No, I agree. I agree, because when you if there's a point at which they've like told us something, but they know, like, because a lot of it's inference, right? A lot of science is inference, and so that's why they do this math, and they do there's a couple things that I think that we as a education like have lost in our general consensus, and it's the order of operations in math and the scientific method. And so,
They're killing people with that right now. They're killing people with that.
but it's the way that it is, and it's like this, it's the way that the English language is structured is called grammar, and we know how to speak English and sound correct because we're putting the sentence structure in the way that it's supposed to be structured, right? And that changes according to like different languages, the way that they structure things, but math is math. It's its own language, so the grammar of it is its order of operations. And those things, like, so we can do the math, but then there's like these inferences that are made from information that we have, but that information itself is a variable, so that can change, which changes the formula, or the parts put into the formula, and then that changes the inference being able to be made. So like in my work, I'm stopped up because people are like, this has only been available since X date, day A, B, and C, but they can't carbon date stone, so how do you know? Like, how can you tell? So let me just go ahead and do my thing, and if it turns out to be something, good, and if it doesn't, no skin off your back, you go ahead and just carbon date shit, and that's that's how we have to kind of look, like, supersede boundaries. Like, you're making like an inference. They're making an inference based on the fact that the Big Bang, or the idea that the Big Bang is a fact and correct, but that's their inference. So all of the things that they're basing it off of are inferred from that. But if you give them something else, you're giving them something else that is a tangible, workable feature, solution, formula, then the inferences can become different. And you're like just in the time, like you're able to see all these new reflections, ripples. You're able to predict things that are going to happen and then be correct because you've allowed yourself to imagine that those inferences could be changed, that the base idea could be different because you're accepting that the base idea in and of itself is theoretical.
Uh-huh.
Yeah,
That's pretty much it.
this is
That's pretty
beautiful.
much it.
It's beautiful.
Yeah.
Well, I'm gonna step off of here and go feed these kids. It was wonderful talking to you, and I will get this to you as soon as I have it ready.
You
I really appreciate you taking your time with this, Fred. And I'm sorry I can't do the whole 6 thing. I will think about it, but I just don't know.
oh no
That
no no no
like
no no
I got
no
panicked for a second. I was like, oh, I don't know if I can do that. I got like,
all no, what I was trying to show you there is the scope of this. When I say we're just getting a piece of it down here, there somebody asked me the other day, are you writing a book? I said, well, I've been writing a book for about 25 years. I've done a rewrite 5,000 pages already. But to me, when I rewrite something, it sounds the same as when I wrote it the first time. George was nice enough to tell me the other day that I use very descriptive writing. You know, I'm not science based. I'm just, Hal Narp told me this same thing. He says, you're a good painter.
Make
Because
the
I had
books
written
better.
this, yeah, I paint you a picture, and here's all it is. I'm not going to tell you, well, this is called that. I'm going to paint a picture of something, then let you decide what you think is real.
Right.
Because, I mean, I'm going to tell you right now, when it comes to these reflections, they don't have a leg to stand on. The Big Bang will crumble underneath this shit under reflections. Because you see, I showed you. Well, you didn't see that before. Now you can not unsee it.
Right. The
You will never
baseball
unsee
one.
it.
Nope.
Yeah.
Definitely.
That's the thing about the truth eventually shows itself. Yeah. You look for it and it will show itself. Sometimes you got to start from zero.
Yeah. But they didn't have Voyager then. Right? We hadn't crossed that line yet. So these are all like fresh new things so that it brings your 25-year observation into the present. It makes it relevant, like all those things that you've been talking about all this time. It brings them down into like it not that it isn't always relevant, but it's relevant in relation to the confirmations that have been made now, presently.
If you go through the videos, you look and notice they're scrambled. They're like my brain. They're all over the place. The biggest problem is Facebook is an advertising format,
Right.
so it doesn't allow me to change it up and reposition all the videos in there, or the memes or anything. So it's just all over the place. But if you just go through the ones that might look interesting, just the ones on space, and pick out this part or that part, you might find that I made predictions in those videos that came true here. I say it like that because for me, I mean, I'm I have this entire book inside my head anytime I want it.
It's so much information.
Every tiny little detail, so there isn't much room for anything else except that.
Right. It's so much, and it's hard to narrow in on all those spaces because you have like it's like each of those spaces is a chapter in and of itself that you have so much information on. So
The big thing here with this is its scalability. It scales from the large to the smallest and shows you everything in between. It's built on that scale. It's built on the electromagnetic field. I show you where gravity is part of the electromagnetic field, is not separate.
Mhm.
That the weak and the strong forces are magnetism, right, left-hand spin. So that this entire theory of the four fundamental forces, they all come under one heading, electromagnetism.
Right.
Even antimatter is included in electromagnetism because it's a basic component of the interactions.
Right.
Uh,
The lack thereof,
yeah.
the lack thereof, the interactions.
Yeah, and that's what everybody really it really is real striking about this is how it paints such a beautiful picture of this balance across the entire universe at a scale that just dwarfs man's ideas,
Mm.
and
Man,
it's just absolutely beautiful.
it makes so many things work that like stopping points where we're kind of blocked up because of the ideas of the Big Bang or ideas of like the way that cosmology is formed, and this kind of informs it in a different way that makes things possible and makes things like it gives reasons for stuff, it adds
Yeah.
clarity to things. So I think that as the future progresses, a lot more of these predictions are going to be confirmed.
And what can I say? They will be. I have definitely found the real universe. Um, I'm not special. I'm nobody big. I'm gonna blow your mind right now by telling you something that I barely graduated high school,
Wow.
zero college, because I looked at college and when I would study, they wanted to teach me everything that I didn't want to know.
Hmm.
I wanted to be an astronomer. I wanted to go into, but I knew from day one that none of that made any sense. Because by the time I was 8, 9 years old, when I was adopted by my dad, who was an aerospace engineer and had a wall full of books, I read 2 encyclopedias by the time I was 12 years old. It just all started coming together that I knew I didn't believe in the Big Bang. It was just all gone past me. It just, for years and years, I just went on with life. I raised a family, raised my kids. Um, about 25 years ago, I come home from playing in a band late night, about 3 o'clock in the morning. I seen the stars in the sky and I seen the Milky Way. And I literally got out of my truck, just looked up there and said, I'm going to figure out what's going on. I think it's time that I looked at what's going on. At that time, I really didn't even know what a nebula was. I knew nothing about astronomy. So I just started digging every book I could. I went to every library I could. Probably read 14 books on astronomy. I still got some. I'm going to flip it around and show you something. Can you see that?
Yeah.
One's a book. One's a book by Burbage. Another is Fred Hoyle's Astronomy. So I really love this idea that one of my favorite phrases, and they're always throwing it at you, is the Dunning-Kruger effect.
Right.
You're so dumb, you don't know you're dumb. Well, here's my proffer to that is that if I tell you a star doesn't explode, and I give you an entire galaxy where no stars explode, no dark matter, no dark energy, no black holes, no neutron stars, no accretion, just nothing. Even the idea of the moon. You ask an astronomer, where did the moon come from? Oh, some giant planet come along and hit the Earth and threw a chunk off. Oh, all right. How about the other 275 moons around Saturn or the other 140 moons around the rest of? Yeah, Saturn's a gaseous planet. Show me the solid surface that sprouted all those. Last count we had 278 moons just around
Yeah,
Saturn.
that's a lot of moons.
But in the picture I just showed you about how planets were formed on a mother rock,
Mhm.
moons are too. All moons, all planets come off the mother rock. A giant ball of lava gets cut, encased in ice.
Mhm.
I mean, you look at all the moons right now; they're all covered in ice. And yet, right now, astronomers cannot tell you where the water came from on this planet. They can't tell you exactly where the moon came from. I've had at least 5 different conversations with 5 AI systems, starting with Meta AI, and I have shown them the lies the Big Bang taught them. I've got these machines believing that I'm telling them the truth and everybody else is lying to them. I end up with them asking me questions about what the reality is.
Right.
So
It's starting to make
the,
sense. But it's
the
okay
moon,
because some of the greatest scientists in history weren't initially that wasn't their initial intent. We were talking about this, like Yuri Korzunov, the Soviet linguist with the Mayan calendar, who figured out that
Yeah.
they were actually syllables, or Wilhelmina Fleming, who was the Scottish maid who became like the astronomical computer, and was
Yeah.
like the first woman ever allowed in the Royal Astronomical Society. So I think that these kinds of things, like you're saying, like the peer review, we started this whole conversation off to like bring it back around to the beginning, right? Like about the journalists and the publications, and it becoming something for what would sell, what was attention getting, rather than and what was agreed upon by everybody, like the general
Whatever sold
consensus.
magazines.
Right.
Whatever sold magazines. It wasn't what the scientists wanted anymore. In fact, the proof of it is in the pudding. You see dozens. I see stories every day, 10 stories a week about journals that are retracting.
Right.
One journal retracted 250 different stories. Another one retracted. Another guy took down his entire site because of this. The incentive to shade the truth a little bit, just to hold up the establishment,
Wow.
pay homage to the mainstream.
Right. Well, I think
You
that
know,
the further we get ahead, I mean, the more we see, I think the more we see, right? The greater the possibilities become, and I mean, throughout history, throughout time, things that people thought or accepted as like concrete, and this is the way that it is. The Earth is the center of the galaxy, solar system. No, it's not. The sun is, right? They had to get past that one, and then all of these types of
but what was the difference? What led this charge? Telescopes. The
but
bigger and the better telescope, the more we could see in space. And I wouldn't be here right now if it weren't for the James Webb telescope.
yeah.
Oh my goodness, we didn't even touch on that. That's one part of what they found out was these layers have ripples.
Mm-hmm.
So you've seen these pictures of what they call gravitational lenses.
Mm-hmm.
They're not.
What are they?
They're ripples on plasma. They're like ripples on plasma, just like I showed you the stars and star
Yeah.
lines. Yeah. Well, you look at a bucket of water, dark water, drop a rock in the middle of it,
Mm-hmm.
and the ripples look just like the galaxies you're seeing on the gravitational lens.
Yeah. Little shimmers of light.
Oh, well, exactly.
And we're only now realizing this isn't a straight line out. It's a gauntlet of invisible forces we're just beginning to understand. This complex interstellar weather creates a dynamic environment that's constantly changing. The boundaries Voyager crosses aren't fixed. They shift and evolve as the sun moves through the galaxy at 450,000 miles per hour. Every new measurement from Voyager helps refine our understanding of these structures, revealing a cosmic landscape that's far more textured and intricate than anyone imagined.
This is from Cosmic Bubbles. Sorry about that. Hit it twice. Okay. You see this? This is a gravitational lens. What did you do that for? Oh, that's even better. I
Perfect.
got lucky. There's a picture of a gravitational lens, right?
Mm-hmm.
From James Webb Space Telescope. And there is a bucket of water with a ripple of a light.
It's like exactly the same.
It is. It's exactly the same thing. In fact, in these pictures, that spotlight there, that's a reflection. But you see the ripple.
And the bending.
Uh-huh. So you're talking about my checklist. Oh, let's see. What's this up here on my checklist? Oh, yeah. First, we have plasma and structure and layers, boundaries, weather patterns, but then what's that?
Ripples.
Ripples. Just like waves on the water. That's what that gravitational lensing is all about. Ain't got shit to do with gravity. You're seeing reflections on the ripples, distortions of images.
And the bending of the
Here,
light.
you recording this one?
Yep.
Okay, so there's all the things we're talking about. There's my checklist. But every one of these words, you'll see them in that video. And each one of these, I've already described to you how the layers and the boundaries work. The plasma comes from the mother rock itself and the jets. And I have videos and other ones up with the jets showing the stars being born from the jets themselves, not just that one we were looking at. Turbulence, magnetic domains, I already explained the domains one to the other. And the turbulence is caused. You see Jupiter and all them ripples between the layers?
Mm-hmm.
That's turbulence between the magnetic layers that I'm showing you in these pictures.
Mm-hmm.
You're going to have turbulence.
The cool picture of the little moon in Saturn's ring that makes it the ring ripple like this is from the Cassini,
Yeah,
but it's
yeah.
the same idea where there's that one. It's like the princess and the pea, like that teeny little thing, and
There
it's
you
just
go.
disrupting.
It's a disturbance. It's a disturbance in the plasma. It's a domains of densities. We already spent on that. The ripples and the low frequency oscillation. That's, to me, that's almost like, a low level oscillation, a sound wave
Yeah.
that's bouncing off that wall. That's the feedback mechanism I've been writing about that makes magnetism stronger at the atomic level. The atom itself reads this feedback
Mm.
when it builds a structure or mass, right? It exists because it's getting this feedback. Look at it this way. When you have two areas of magnetic domain in space, they're equal in volume, right? There's no growth mechanism, no expansion, nothing. You cannot create mass from two things that are equal. But when you have a feedback mechanism, you control that imbalance, that balance or imbalance. And when you start to build mass, one side of that magnetism is just slightly stronger than the other. That's where your outward expansion comes from.
Mm.
Without that slight imbalance at the molecular, at the atomic level, you don't have any mass. You can't build atoms. All that is built, is caused because of this field that the mother rock makes and the plasma is generating. Also, you got nucleosynthesis in that plasma that's creating all the elements. I always loved the idea in the Big Bang about accretion disk theory. How did the planets come about? Oh, well, there was a big old ring of dirt around the star. Where'd the dirt come from? I thought the Big Bang said it was all hydrogen blowing out. You know, somebody bring a pail and a sandbox on to the beach or what? Oh, yeah, this is where the dirt is what helps recycle the galaxy itself. Each galaxy recycled in its own little cocoon, you might say. And that's why there's a big space between the galaxies. We're all floating inside a big fuel tank, giant gas tank, ready to go boom.
Swirling around in there.
Yep. The trick is the bubble itself. At the outermost level, it's made of what's called BECs, Bose-Einstein condensates. They link up in a hexagonal structure,
Mm.
and then freeze in that structure, and then layer, so that these layers can slide past each other.
Mm.
So it allows this bubble to expand and contract. So what is a bubble? It's skin.
I was thinking like the fascia. Like the fascia layer between your skin and it's like the
It's a,
casing that everything is in.
there you go. It's the skin itself. The bubble is just like the skin around your body, keeping that electromagnetic field in your body.
Mm-hmm.
The skin around the bubble keeps that electromagnetic field to where it can be controlled and controls the atoms and electrons in and creates mass.
Mm-hmm.
And it creates, I read where a lot of I don't know about Feynman, Oppenheimer, the rest of them. They all speculated there was a little bit of antimatter inside of every atom. And I really don't understand or can't do physics or equations or anything, but I see quantum mechanics as describing one little piece of antimatter is a quanta.
Wow.
And the more it generates, that's a controlled fusion process that works its way upward.
Wow. So it is scalar.
Mhm.
It's just
Yeah.
it's scalable.
Like I told you, the same thing happened at the atom is happening at the galaxies. I said I'm far from being the smartest around. I'm probably one of the dumbest you'll run across, but I just happen to be lucky enough to put the pictures in the right order.
Yeah, you did. You're lining them up pretty nicely. You're like a puzzle piecer. A friend of mine, we called ourselves the puzzle piecers because there's all these bits all over the place, and it's just about seeing how they fit together. You know?
I'm wearing glasses that I get at the little drugstore or whatever. Those cheap $12 fake. But, I used to do puzzles all. Oh, I loved them. Last time I did a 1,500 piece puzzle in 17 hours.
Wow, that's dedication. That is.
Like 2 days, like not even 2 days.
Oh my
So
gosh.
I could put puzzles together like crazy. When,
See,
when I
you got
used,
the knack for it.
yeah, and crossword puzzles. I had somebody ask me one time. I said, "I'm the only one I know that does them in ink."
You don't need no eraser. Well,
No, I don't. No.
damn, I wish I was that good at it. I am not. But thank you. Is there anything else like where people can find your work on Facebook, and you have a YouTube channel?
Yeah, that's the two main ones. They're trying to start me on TikTok and Instagram and try and get on the other ones. Uh, but I don't see that as being the solution to all this. I see sometime, and I'm going to have to make a website
Yeah, I agree.
because
You have
I
too
just,
much information to. It has to be
Facebook
compiled
can't
and.
handle it. None of these sites can handle what I have. It is so immense. You're seeing just the tip of the iceberg, and but just to get that out,
Mhm.
just to get this out with what's happened to me recently was finally meeting somebody from NASA.
Yeah.
Oh, that was
And
so
having
fucking
such a
incredible.
wonderful positive experience with that, such a positive
Oh,
output
I
feedback.
can't believe it. I can't believe his reaction to it. He was just, for a better lack of term, he was giddy.
Nice. Yeah, I saw that Facebook post, and
Uh,
he was quite happy to meet you and exchange books and autographs
this,
and everything
this
else.
was this was the shirt I had in the car. I should have been wearing this one. I caught me. He all of a sudden, let's go take a picture. Okay, and I had that blue shirt on it. Oh man, now the
That's
whole
all
world's good.
right.
I told him when we walked in there. I said, "We're about to make history."
Yeah.
Huh? Yeah. But I had been talking with George for about 4 years since the pandemic. My father had actually been to Johnson Space Center before it was named Johnson Space Center. It was manned space control, and I got a document where he was in charge of a contingent. Oh, oh, it's on my webs. It's on one of my videos. See that?
Hmm.
That's a history book, baby.
Yeah, it
History of
is.
rocketry. And what you find in it, you go back here, and you will see R.B. Gangstad.
And that's your dad?
That was my dad. He was part of a contingent to early lunar base concepts, the Lockheed Experience Part 1. He was in charge of that's what it says there, was he was giving the report for the trip. So I know he was in the space program. He was a top level black book engineer.
Wow.
The stuff he worked on, he could not talk about to him. He couldn't talk about it to my mom, to anybody, but he actually talked about it to me because I read all his magazines before he got home. He got so mad at me one time. I was telling him all the stories. He said, "Can I read my own book?" Mm. But yeah, we would
Well,
have talks about humans exploration as versus robot, and he wanted robots to go into space. Oh,
Yeah.
we got to work everything on robots. We don't want. I don't like to. You know, after Apollo 1, you could tell he was distressed that people had lost their lives in
Right.
this project, and he was all for robots going out there. I said, yeah, but they're just going out there to get ready for us to follow them. You know.
Yeah.
So there it is.
Yeah. Well,
They're getting ready
technically,
for us to.
he was right. I mean, Mars rover is a robot. You know, like
Yeah.
they've been out there before
I
us.
was, my name went up there with curiosity. They took a nameplate, everybody put their name on it and everything. I
Oh,
put my name on it. I got a
nice.
certificate. That's cool.
Thank you so much, Fred. I really appreciate your time. Thank you for sharing all of this amazing information today. This blows my
Well,
mind. It's
anytime.
incredible.
I mean, oh, I can't say enough. I mean, I've been working at this a long time. I say I've been writing this for 25 years, but actually, this all started when I was 2 years old.
So lifetime labor of love, and look at the fruit it's bearing. So thank you for doing it.
And next time I might have my beard grown.
There you go.